Welcome to Brain Vision.
To solve this question, we're going to consider that the absolute value of psi squared is written as this. It's r squared divided by 6 a naught to the fifth e to the minus r over a naught. And the probability density as a function of r pr dr is equal to psi squared times 4 pi r squared, the area dr. So to start, we're going to find the probability of finding an electron between r and dr from the nucleus. We just need to simply replace psi squared here and then take the derivative of the probability density with respect to r, set it equal to 0, and solve. So go ahead and start doing that. We have PRDR is equal to, we're just replacing it with the probability density here. So we have this being equal to 2 pi r to the fourth divided by 3 times a naught to the fifth. So all I did was replace that psi squared value with that in our equation, and then multiplied by e to the minus r over a naught. And the most likely to occur is when the derivative of the probability density, P of r with respect to r, is equal to 0. So we need to take the derivative of this with respect to r and then set it equal to 0 and solve. So we have d by dr of the equation 2 times pi times r to the fourth divided by 3 a naught to the fifth times e to the minus r over a naught. And again, this is equal to 0. So using the product rule here, we find that this is equal to, we can go ahead and pull the constants out front. So we have 2 times pi times 3 over a naught to the fifth. Those are all constants. And then we're using the product rule here on the rest. We have e to the minus r over a naught. So we're going to take the derivative with respect to the first r to the fourth value. So this is times 4 times r to the third plus r to the fourth. And then we're going to take the derivative of what's in the exponential. So this is e to the minus r over a naught times the derivative of what's in the exponent, which is 1 over a naught, negative 1 over a naught, excuse me. And this is all equal to 0. So we can first divide both sides by that constant that's out front, so that's going to go away. We also have e to the minus r over a naught values in both, so we can divide by that, and it's going to go away. So what we're left with, switch back to the black marker here. What we're left with is 4r to the third minus r to the fourth over a naught is equal to 0. So solving for r, we find that r is equal to 4 times a naught. And that's the most probable value. So we can go ahead and box that in as the solution to our question.